Our next topic is going to be rational expressions. We're going to look at how we can simplify them, perform arithmetic operations on them. But first we want to define what a rational expression is, and it's just the quotient of two polynomial expressions. And I should say of. So we have a polynomial expression divided by another polynomial expression. When we talk about simplifying rationals, we can do that by canceling common factors. What we need for that then are values that are being multiplied together, not added and subtracted from each other, but values that are being multiplied together are factors. If we have common factors in the numerator and denominator, like we do in example 1, we have y over y. Those cancel out since anything divided by itself would be 1, leaving us with just 8y minus 3 over 6y minus 5. Similarly, in example 2, we have 6a plus 7 occurring in both the numerator and denominator. Those common factors will cancel each other out, leaving us with 8a plus 7 in the numerator over 6a minus 3 in the denominator. Examples 3 and 4 are the same, except now we don't have factored expressions. We have binomial and some trinomials. Before we can simplify, we first need to factor these expressions. We can factor b squared minus 9 using difference of squares. So this will be b minus 3, b plus 3. And in the denominator, we need to look at factors of 15 that will multiply together to give us negative 8. Since we need to take two values and add them together and get a negative, but we want them to multiply together to be a positive, we actually want to consider negative factors in this case. For instance, negative 5 times negative 3. Adding those together would give us negative 8, which is that middle term that we're after. Since our leading coefficient is 1, that's all the more work we need to do to know that this will factor as b minus 5, b minus 3. Now we can look at any common factors, which in this case would be b minus 3. Those will cancel, leaving us with b plus 3 over b minus 5. As we move forward, we're going to assume that we're getting more and more comfortable with factoring, and we're going to skip over those steps. But I will encourage you to work through these, make sure you know how to do that, and reach out for help if you're having trouble factoring any of these. In example 4, we should be able to get the factored expression of a minus 4 times a plus 2 in the numerator divided by a minus 4 times a minus 2 in the denominator. A minus 4 over a minus 4 will cancel, leaving us with a plus 2 over a minus 2. Again, as we continue working with rational expressions, factoring is going to be critical. We're going to assume that we've gotten some review and practice with that in a previous section, but if you need help with that, if you're having trouble getting these answers, be sure to reach out for help with these.